Welcome back to Advent of Code 2024, Day 3. We are up to a total of 4 stars. We have now Mull It Over. We have the lore on screen. If you want to read that, I will summarize the question now. We're going to be given a string here as an input, and there are going to be bits that are highlighted that look like this. MUL left parentheses, some number, then a comma, and then another number, and then a right parentheses. There are also going to be examples that look very similar, like MUL brackets and do not mull, and then we have MUL parentheses, but a right bracket. So we're looking for every instance in the string that matches that pattern exactly. So these numbers here, they can be 1 to 3 digits. And so what we need to do is scan the entire string for all of those instances, and then take each of those two numbers, multiply them together, and then add together all of those products to get the answer. Pretty easy. For the solution, I think I'm going to solve it as we go and do the process instead of just showing you the end result. Maybe it'll be more fun. So my algorithm, I'm not going to utilize any regex or anything like that. I want to do something more interesting. I want to just go left to right, character by character, as we parse the string, with storing as little memory as possible. Just check this character. If it's the one we're looking for, go to the next one. If it's one we're looking for, go to the next one. And so what we should do is we should look for an M and find it, then look for a U and find it, and then look for an L and find it, and then look for a left parentheses and find it. And then this is where it gets interesting. Once we find that left parentheses, we need to then switch modes and say, let's start parsing some number. And then let's look for a comma. And then let's parse another number. And then let's look for a right parentheses. And so then if we take a good path through this value and we get to the right parentheses and everything else checked out, if we've stored the numbers that we parse as two different numbers, we'll just do the math with those values, reset everything, and then go back to looking for an M. And then if we start scanning and we find some characters MUL, and then we find something we didn't expect, we'll just reset everything and go back to looking for an M. And it's going to be really fast, really easy. So my code here already looks like this. We are going to set some sort of scan target for the character we want to look for, and then set my number mode if I'm parsing the number or looking for my target. And then these are the two values I said I'm going to use to store those parsed integers. And then we are looping through every index of my data for every character. So then if I'm in number mode, do something else. But if I'm not in number mode, check to see if my character matches the scan target. If not, reset back to looking for M. And here, what I'll need to do is I'll need to reset these two. I'll say N1 equals 0, N2 equals 0. But if I do find the character that I'm looking for, great. Let's now set the scan target to the next character. So M goes to U, U to L, L to the left parentheses, and then left parentheses to comma. That's maybe not what you expected, but also set number mode to true, set N1 and N2 back to defaults, and then same thing, comma, then goes to right parentheses, and set the number mode to true. And then once we get to the right parentheses, that means that that's good. Our pattern was found. We'll do some math there. And so the reason this is happening, the reason we're setting the scan target here, is because once I get here and once I start parsing my numbers and I finish parsing my numbers, I don't want to know which number I'm parsing. I just want to move on to the next character. And so when we run our program here, we're going to see that the first character, we found an X, but we were looking for an M. And then nothing else. That's because I'm setting my number mode here. And if we turn that off for a second, we're going to see a different thing happen. We're going to find that we found an X, but we were looking for M, and that comes from the first character here. And then we found a 2, but we were looking for a comma, right? So we found this, but we were looking for a comma. And that makes sense, right? This is the point where we found this. We need to handle that number mode. So that's what that's doing here. So back in my code, this else statement is handling when I'm in number mode and I'm looking at a character. And there's a couple ways that I could check to see if my character is a number. I could just coerce it to a number with the number constructor. And if it's not a number, I'll get the not a number value. And that seems fine. It would be very JavaScripty, but I don't want to do that. I could use parse int, and I could feed it my whole data and the index I'm looking at, and I'd get actually the whole integer, the multiple digit integer, but I don't want to do that just because for fun. Instead, I want to look at the character codes, and you can look at an ASCII table and find that the character 0 starts at 48 and 9 goes up to 57, right? So those are the ranges. And so if I get the code of my character and it's outside of that range, then we need to reset all of those values. Otherwise, we've found a digit. And when we run our code here, that's what we find. We find that we enter number mode eventually, and we find 2437 and so on. And our input here says 2437 and so on. So that's working. That's good. So we're going to do something pretty simple. Instead of casting it to a number, we're just going to do the calculation manually, right? We have the character code of the character, and we know what the character code is of the digit 0. So we'll just take our code minus the ASCII code of 0, which is 48, and we'll say code minus the ASCII code of 0. That equals our value. That's basically how that works. And so when we run this, we're going to see that, yes, our character 1 gets a value of 1. Our character 4 gets a value of 4. That's what that line is doing. And then what we need to do is we need to start to manipulate this number 1. And we're going to do so with a really simple thing. We're going to say, let's take all of the digits that are in there and multiply everything by 10, which basically shifts everything over to the right to give us a new space. And then let's add our value there. So we know that we're only ever going to be working with single digit values. This works. It's cool. It's fun. This is n1 equals n1 times 10 plus value. And we're printing n1 before and after. So when we look at these here, we're going to see something really not interesting. We're going to say that the character 2 was found. We're not going to see anything interesting until we get to the double digit values, so 3 and 2. And when we do, we're going to see down here what's happening. We find the character 3. It has a value of 3. N1 goes from 0 to 3. And then we find the character 2 with a value of 2. And N1, which we stored 3 in a minute ago, we're going to multiply by 10 to get 30, and then add 2 to get 32, right? This is kind of reverse engineering parse int. It's kind of fun, and I just like doing it. It's fun. And so for the last bit of the solution, I had a realization. I realized that I'm going to be in number mode when I find this comma and when I find this right parentheses. So I'll be looking for numbers and I'll accidentally have found a comma. I've moved that case out of the switch statement. They are no longer here in this switch case. Instead, I've just put these if and else if before we check for if it's a digit. And so if I'm in the number mode and I find a comma, then I need to say that n2 equals n1 and n1 equals 0. And so basically that says the number I was parsing, let's move it to a different register. And then let's set this register back to 0. Let's reset that. And then if I find my right parentheses, if I've done everything right, let's do my math here. Let's take those numbers that I found. The first one I found has been moved earlier when we found the comma. And the second one that I've been reading is now in N1. Let's multiply those together and add it to the sum. And then reset back to not number mode and scan for the next letter M. Once I do that, it just works. If you're following along, you realize what I'm doing is exactly what I showed you. I'm scanning for the letters. Once I find that I should be looking for numbers, I do that. And once I find digits, I'm adding them incrementally into this register N1. And once I find the comma, I move that to a different register and I start scanning and just doing the same logic, shoving those numbers into N1. And once I find that, I've got two numbers. Multiply them, add them together. And so that's the trick. That's the magic. Let's take my real puzzle input here, shove that in there. Let's point our file path to the real input. I've gotten rid of all of the console logs that we don't need, and we run it and we get a sum of 188 mil. Let's see if that is the solution. Nice. Now time for part 2, and this changes it up quite a bit. So the basic idea is that now scattered throughout this string, there are going to be bits that say don't and do. And what that means is that we're going to start to be able to turn on and off these mul instructions. By default, we're going to say that it's on, right? So we're going to be able to say that this multiplication instruction, since it's on, should be executed. And then once we get to the don't instruction, this next mul, which looks valid, let's not do that because we've turned it off. And then once we get to this next one, it's still off, but then we find do and we re-enable and we find the last mul. And so what I'm happy about with mine is that since my solution just goes left to right, I'll be able to just turn this on and off. But what I'm not excited about is that since I'm not scanning for just an M and I could now find a D, that's going to be a little tricky. And since this character and this left parenthesis overlaps with this, I'm going to have to do something a little bit more interesting to be able to get this done. And so the basic idea is that I've introduced an enabled flag that's here. And so if I'm looking at these if and else bits, that's what we had originally. If I'm enabled, look for that mul command. But if not, just don't even look for that. And so since now that I have these options of I could look for the mul command or I could find the do and don't commands, I've just changed this to be a primary scan target and a secondary scan target. So if I'm looking for the mul command, or if it's off, then I can always still look for do and don't. And so that's what this is. If I'm looking and I find the next scan target, handle that. It depends if I'm enabled or not, whether or not I'm looking for do or don't. So if I'm disabled, if I'm in this else block, I need to look for the word do. And so this is just the same logic as above. Look for the right character and then move the target to the next one. And once we get to the end, we'll just set enabled true. We found do. But if I'm disabled, do it the other way. But if I am enabled, I'm looking for the word don't in order to turn it off. And if we find the end, if we find that don't command, we turn it off. So that just toggles the enabled flag. And then that is used here. And we get the correct answer for our test data. We get 48. Now we'll run part 2 on the real input. This hasn't changed from the first part, so that's good. With our first solution, we had 188 mil, so we should get significantly less than that. We get 113 mil. Let's test if that's right here and cross our fingers. Of course it works. It's code. A fun thing to note is that took my program 1.3 milliseconds. So if yours ran faster, post it in the comments. And if it ran slower, maybe you'll learn something. And now my calendar looks like this.